Good morning, Tehmina Khan is here in TKMaths is fun. In today's video, we will solve a question on integration, which has partial fraction also in it. Sorry for the spelling mistake here. Let me correct it right now. Okay, so this topic is from A-Level Mathematics P3. And I have taken this question from November 2004. It's question number 8. Now, before we start, you can see my website address. And you see, I have put up all the topics of the P3, A-Level Mathematics topic here. If you go in the challenging question, you will find this link there. You just click on the topic and you will see all the videos I have made so far, or I keep uploading videos here. So it is a good source of revise the concept. Now, according to the syllabus of integration, there are 6 aspects you need to know. In this video, I am covering this point, which is saying integrate rational function by means of decomposition into partial fraction. So this aspect we will cover in this syllabus, in the video. So you need to recall the 3 special cases we have in the syllabus for partial fraction. And these cases are identified with the help of the denominator. Now here is the denominator which has only linear functions, maybe 1, maybe 2, maybe 3, depends on the question. In this case, it is 1 linear and then quadratic. And in this case, it is linear and repeated case. And this is how we generally break it up, right? I hope you remember it. In case of linear denominators, we just write constant a, b, c in the numerator. In case of quadratic, we write bx plus c. If you want to write this first, then you can write ax plus b over this plus c over this. So basically, this form is important. And in case of repeated, you see, above linear, we are writing constant. Then for repeated, how we are increasing? 1 power at a time. So it is power 1, then power 2. If I had here 3, I would have written 1 more time, cx plus d power 3, and constant in the numerator will be t. So I hope you need to recall this. Remember, in your syllabus, those cases are not included which have bigger degree in the numerator bigger than the denominator. So you have only proper fraction and those improper fraction which have same degree in numerator and denominator. For more detail on partial fraction, you need to see videos on, especially on only partial fraction questions. Okay, so this is the question. It has 2 parts. In this question, the easy thing is, examiner is already telling you how to break this up, right? He has given you this hint here that if there are 2 linear functions, then you break it up like this, decompose like this. So in part A, he's just asking you to decompose without evaluating any constant. We don't have to find the value of the constant. We just have to write in the general form how they will look like in decomposition. And after that, we have to integrate this and show the exact answer, ln 4. Now, this is very important where you have to show exact answer. You cannot use calculator decimal values all the time. So we will see this in detail. So let's see the solution. I have just shown you in the partial fraction decomposition that quadratic is broken up in a particular form. So here it is, you can see. So this is a question in blue. When you're decomposing it, this is your linear function and this is your quadratic function, which cannot be factorized further. So it will be constant over x plus 4, and this is quadratic, so it will be bx plus c over this. And that is all you have to do. Now let's see part 2. Now if we see here, we will recognize it is linear and it is repeated. So whatever is the technique of linear and repeated, we will apply that. Just a minute. A, B, C. You can see power 1 here, right? And power 2 here. So this is all you have to do in part A. Now let's solve part B, where you actually have to integrate it, right? So I'm just picking up this function which I have to integrate. Now you need to know here that when you are integrating a function which is given or reminds you the partial fraction case, so actually you have to decompose it first and then you can integrate it. Because in integration there are 5-6 types you have studied in the syllabus. So this is a partial fraction type case. So now you will find out these constants, right? And technique is like I will take LCM. So A will multiply by this, B will multiply by this. After that, because on the left hand side I have this function, denominators are same, so I can equate 3x is equals to numerator. Now here you have two forms to solve it, two methods rather. One method is comparing the coefficient. In comparing the coefficient, you open it and compare the coefficients of the like terms. I have applied here second form, which I like more, second method, and that is substitution method. Because it is an identity, you can take any value of x on both sides. So I take those values of x which make one of the factor equals to 0. So if you see here, if I put 2 here, it will become 0. And if I put -1, it will become 0. You can take any value, but if you take those particular values which will turn one of these terms 0, then your calculation will be faster, right? So I am putting x equal to 2 in this whole identity, and it will help me to get the value of b. So I got b2, which I will write here little later. Now I have to find a, so I am putting x is equals to -1 in this identity. Now when I plug in here -1, I get a is equals to 1. So now in my decomposition of this partial fraction, I can write 1 here and 2 here. So it will become this. Now I will come to the question, because actually we had to integrate it. So question was saying integrate this, and the limits were, there is a misprinting. I'll just see what is the limit here. Let me see here. It was 3 to 4. Okay, so this limit was 3 to 4. Give me a second. Let me write here. It was 3. Okay, so now instead of this function, I have decomposed it here. So I will use this function and I will integrate it. And limits will be 3 to 4. Now, there are two terms. I'm considering them as a separate term. So I'm integrating them separately. You can do it in one go. Because I wanted to explain, so I am trying to make it easy. If you are in practice, you can directly do it. Now, what does this remind you? What type of integration it is, if you see? Now, if you see here, you need to recall one of the method of integration in which if you have a function in the quotient form such that the numerator has the differentiation of the denominator. It means if you differentiate whatever is in the denominator and that differentiated function is given in the numerator, then your integration will be ln of the denominator. So you just write it like this, right? So if I differentiate x plus 1, what my answer will be? See, if I differentiate x plus 1, my answer will be 1 plus 0, which is 1. 1 is present in the numerator. It means this side will become ln x plus 1, right? ln x plus 1. I'll just explain this side in a minute. And I'm applying limit 3 to 4, right? ln x plus 1, limit 3 to 4. Now see here in this case, the denominator is x minus 2. If I differentiate it, it will be 1 minus 0 over 1. Do I have 1 here? No. I have 2 here. So what should I do? Can I take this 2 outside? If I take this 2 outside, I will have 1 here because 2 ones are 2. So it means if I integrate this, it will be 2 times, because 2 will come out and 1 will be here. So 2 times ln of this. So this is what I have done here. And the limits will be 3 to 4. After that, we know we apply upper limit minus lower limit. So I will apply 4 here and then minus 3 here. Similarly, I will do on this side. I have used different color to make it obvious. So you see 4 plus 1 is 5, 3 plus 1 is 4. Similarly, upper limit is 4, lower limit is 3. 4 minus 2 is 2, 3 minus 2 is 1. And we know ln 1 is 0. So this terms will be eliminated. So ln 5 minus ln 4 plus 2 times ln 2 and 0. Now, if you see, the question was saying, if you remember the question, write it in the particular form. What was that? Put it equals to ln 5. Let me show you here. Here, after integration, you should get ln 5. So what we have gotten so far is this. If that particular form was not given, I would have applied all this in the calculator and gotten the value in decimal maybe. But right now I have to show each and every step to get ln 5. So now if you see here, this term can go here. If you remember the power law of log, right? So it will become 2 square and this will be 4. Now plus ln 4 minus ln 4 will cancel out and you will be left with ln 5. So this is what you have to prove. So thank you very much for watching this video. Please share with friends and press like and subscribe button to encourage me. Thank you. Take care. Allah Hafiz.